Imagine a world without smartphones, televisions, or life-saving medical equipment. That's a world without rare earth elements. These 17 metals aren't always rare, but they're rarely found in minimal concentrations. They're the hidden power behind our technology. Vivid screens, electric cars, wind turbines, and especially the semiconductor chips at the heart of modern electronics. Unique properties make them indispensable. Neodymium for magnets, europium for screen colors, and yttrium for lasers and chip manufacturing. In chipmaking, yttrium is crucial for protective coatings and insulators, shielding machines from corrosive plasma. Without a stable supply, the entire tech ecosystem, from laptops to military hardware, becomes fragile. For decades, the world has relied on a single primary source for these elements. That dependency is now a critical vulnerability, worrying leaders from The Hague to Washington. China has built a near monopoly on rare earths, not just mining, but refining and processing, which are costly and environmentally taxing. By 2025, China produced 88% of the world's refined rare earths, making even foreign-mined ore dependent on Chinese processing. Heavy investment and willingness to bear environmental costs let China undercut global competitors and dominate the market. This gives Beijing a powerful lever. It can restrict supply to reward allies or punish rivals. In late 2024, China flexed this muscle, imposing export curbs on gallium, germanium, and then yttrium, choking supply with bureaucratic bottlenecks. The message: restrict our tech access, and we'll restrict your access to the materials you need. Countries like the Netherlands, leaders in semiconductor equipment, are caught in the crossfire. Rare earths have become weapons in a high-stakes economic battle. In Dutch semiconductor cleanrooms, a crisis brews. ASML's photolithography machines, vital for global chipmaking, rely on yttrium oxide coatings to survive corrosive plasma etching. China's export controls on yttrium in April 2025 severed over 90% of the world's supply overnight. US imports stopped. European supply dropped by 30%. For Dutch factories, this is an existential threat. Industry insiders rate the shortage a 9 out of 10. Without yttrium, new chip equipment production stalls and existing machines can't be properly maintained. Delays mean costly downtime and fewer chips for everyone. The industry is scrambling for alternatives, but qualifying new suppliers or materials takes months or years. For now, the Dutch chip sector is on edge, watching the geopolitical chess game with growing urgency. The world's tech supply chain has never felt more fragile. The yttrium chokehold has sent global markets into chaos. Prices for yttrium oxide in Europe have soared by 4,400% since January 2025, reaching $270 per kilogram. Manufacturers face skyrocketing costs, which ripple through to everything from cars to washing machines. Smaller companies struggle to compete for scarce supplies and risk going out of business. Panic is spreading, procurement teams scramble for shipments, and executives hold emergency meetings. The fear isn't just higher costs, but total production shutdowns. The just-in-time model is exposed as a liability. Companies now rush to stockpile, driving prices even higher. This creates a vicious cycle. Scarcity breeds more scarcity. It's a frantic race for survival in a market turned upside down. China's export restrictions have jolted the world awake. Governments and corporations are racing to break free from this dangerous dependency. A coalition of the US, EU, Japan, and Australia is fast-tracking new rare earth mines in friendly countries, prioritizing security over cost. The real challenge: building refining and processing capacity outside China. In Indiana, ReElement Technologies aims to produce 200 tons of yttrium oxide annually by late 2025, with plans to double output. Similar projects are underway in Europe and Australia. Recycling is another frontier. Recovering rare earths from discarded electronics is gaining momentum. Scientists are also developing alternatives, like new magnets that don't require rare earths. These solutions will take time, but the crisis has injected urgency and funding into innovation. The world is determined to build a resilient supply chain. This crisis is the result of years of escalating tech rivalry between the world's largest economies. For decades, global supply chains have relied on a delicate balance, one that's now unraveling as nations compete for technological dominance and critical resources. In December 2024, China curbed exports of gallium and germanium, signaling its willingness to weaponize minerals that are essential for everything from semiconductors to advanced military systems. The move sent shockwaves through global markets and raised alarms in capitals worldwide. The real escalation came in April 2025 when China imposed controls on yttrium and 6 other rare earths, directly targeting high-tech industries like electronics, green energy, and aerospace. This marked a turning point, as companies and governments realized just how vulnerable their supply chains had become. The world scrambled to respond. By May, the US, EU, Japan, and others accelerated plans for joint procurement, strategic stockpiles, and new mining projects. International cooperation became urgent, as leaders sought to reduce dependence on a single supplier. The race to build an alternative supply chain was on, but everyone knew it would take years to develop new sources, ramp up production, and secure reliable transport routes. The world faced a long, uncertain road ahead. Tensions peaked in October, as China tightened restrictions on even more rare earths and battery materials, further squeezing global industries and fueling fears of a prolonged standoff. A Trump-Xi summit in South Korea led to a partial truce, easing some restrictions. But crucially, the limits on yttrium remained, leaving a critical gap in the supply chain and uncertainty for the future. The global chip industry remains in crisis with no quick fix in sight. Production delays, rising costs, and supply shortages continue to ripple across the world. The stakes have never been higher, as the world races to adapt to a new era of technological competition and resource scarcity. This isn't just a trade dispute, it's geopolitical chess, where every move is calculated and the stakes are higher than ever before. The world's most powerful nations are locked in a contest that goes far beyond tariffs and quotas, shaping the very future of technology and global influence. China's mineral restrictions are direct retaliation for Western tech controls, creating a tense, "you block our chips, we block your materials" standoff. This tit-for-tat escalation is not just about economics. It's about who controls the building blocks of tomorrow's industries, from smartphones to electric vehicles. But Beijing's strategy is more nuanced than it appears. By selectively applying and suspending restrictions, China sows uncertainty, divides US allies, and maintains crucial leverage over global supply chains. This approach keeps its rivals guessing and its own options open. Countries like the Netherlands now face tough choices, forced to weigh the benefits of US alignment against the economic pain that could come from angering China. For many, the cost of picking sides is growing, and the pressure is mounting. Domestically, China uses this time to accelerate its own semiconductor development, while disruptions in Western supply chains buy it precious breathing room. Every delay in Western production is a chance for China to close the technology gap. The ultimate goal is clear: achieve technological self-sufficiency and become immune to foreign pressure. By investing heavily in research and manufacturing, China aims to control its own destiny in the tech world. China's dominance in rare earths and batteries gives it powerful cards to play in global politics, allowing it to influence everything from green energy to defense industries worldwide. For the rest of the world, this is a stark lesson in the risks of over-reliance on a single supplier. The vulnerabilities exposed by these supply chain battles are forcing countries to rethink their strategies and diversify their sources. Economic interdependence, once seen as a guarantee of peace and prosperity, is now a source of both connection and conflict. The same ties that bind nations together can also be used as weapons in this new era of competition. The balance of power is shifting before our eyes, and the world is watching, waiting to see who will make the next decisive move in this high-stakes game. The rare earth crisis marks a pivotal turning point for global technology, sending shockwaves through industries and governments alike. As the world grapples with shortages and supply chain disruptions, the importance of these critical materials has never been clearer. The era of prioritizing cost above all else is over. Now supply chain security and resilience have become the top priorities for companies and nations. Businesses are rethinking their strategies, seeking to minimize risk and ensure steady access to vital components. For chipmakers, this shift means navigating ongoing uncertainty, facing higher costs, and dealing with longer lead times. The pressure to adapt is immense, as the stakes for failure have never been higher. In response, the world is investing billions in new semiconductor fabs, rare earth mines, and advanced recycling plants. The goal is to diversify sources and reduce dependence on any single country, especially China. through a China plus one strategy. Innovation is accelerating at an unprecedented pace. Scientists and engineers are racing to develop alternatives to rare earths, invent new manufacturing methods, and create more sustainable solutions for the future. The industry may ultimately emerge stronger, with a more diverse, resilient, and robust base that can better withstand future shocks and disruptions. The world is rapidly shifting from a single, interconnected globalized system to competing technology ecosystems, one led by the US and its allies, and another by China and its partners. This new landscape will complicate business, increase costs, and may slow technological progress. But it's a reality that companies and governments must now face head-on. Technology and national security are now inseparable, with governments taking a more active role in shaping the future of critical industries. The future of chips will be shaped not just in research labs, but also in mines, refineries, boardrooms, and the halls of power worldwide, where decisions made today will define the next era of global technology.